So I think you're right. I mean, it is quite interesting how the code is developed and how it's engineered and how in some cases it's kind of self-building and self-improving. However, it's what we do with it that makes the difference. And we're seeing it accelerate the pace of analysis of data, the wealth of project data we might have, or subsurface data, tunneling data, bridge data, risk data. There's a lot of work to do. And thinking back to my time working in PMOs on construction sites, there was a lot of heavy lifting. Now with an AI agent and automation, it can cut through that data, organize it for us, pick out trends, pick out anomalies. What we shouldn't do is ask it to do the job for us in terms of decision making, but it does do a lot of the heavy lifting in a more automated, faster, also understanding how our investors take it as well. They're viewing AI as a really exciting addition to our sector: design, engineering, construction, optimizing construction, and of course asset management. But they do want to know that it's the right stuff and being used in the right way. So I welcome governance. We mustn't over-govern it because we could suffocate it. So I think a responsible and flexible set of principles, standards, rules, accreditations, like most new arrivals to our sector, would be welcome to keep us all in good order. And what's really exciting is that a digital twin, we start building it in the design phase. So you lay out what this asset is going to look like and then the path to getting it. And that can be project schedules from a planning perspective, risk logs, how extended the supply chain, how fragile the supply chain is, which components come from which supplier and in which order are they assembled. That's all really important information for maybe 5, 10, 15 years down the line when the asset's handed over. And historically in some projects, we forget to do that. Who put that bit in over there? Who engineered that pump house? Well, I've got a couple of PDFs or a memory stick. All of that goes. A living digital twin, in our opinion, starts at the earliest stage of the project and it builds, and it's a repository for all the planning, investment, supply chain, design, engineering, construction data, so that when you hand the asset over, you get two sets of keys. You get the keys to the asset itself, to the new owner, fantastic, and the ribbon is cut. And then you get the digital keys. So tell me that technology and data story right from the beginning. And it really is a once-in-a-time moment. And I'm really excited that digital twins that live the full duration of the project have such rich and well-organized data. But whoever the asset owner is when they get them, they're going to really benefit from a really solid footprint, legacy, and heritage and journey of every element of that project.
Join us for your weekly deep dive into the beating heart of UK construction. From groundbreaking projects to game-changing innovations, the UK Construction Podcast brings you face-to-face with the industry's brightest minds and boldest thinkers. Each episode features candid conversations with construction leaders, architects, engineers, and on-site experts who share their hard-won insights and behind-the-scenes perspectives. We cut through the noise to deliver actionable intelligence on market trends, emerging technologies, and the forces shaping British building.
Nathan, thanks very much for joining us. Thanks for your time this Sunday. Hope you're well.
It's a pleasure. Yeah, very well. Always great to see you and delighted to be here. Looking forward to the conversation.
So am I. So let's start then. Can you start by telling us a little bit about yourself, who you are, what you do at Bentley Systems, and what the company does?
So I'm Nathan Marsh. I'm the regional executive for Europe, Middle East and Africa at Bentley Systems. That's about 1/3 of our business territorially and about 1/3 from a kind of revenue perspective. I've been at Bentley for 2.5 years. I've been a customer of Bentley's for about 8 years when I was at Costain, Atkins and other engineering consultancies. So I know the organisation well, know the sector well, and yeah, delighted to be here and delighted to represent Bentley, but also give you a perspective from my career journey as well on our brilliant industry.
Great stuff. So we had a little chat before to prep for the call, to prep for the interview. You said to me that the more interesting point is not how AI code works, but how AI and better data change the way we plan and manage complex infrastructure. We'll talk about a couple of case studies shortly, but first, what's the biggest shift you're seeing?
So I think you're right. I mean, it is quite interesting how the code is developed and how it's engineered and how in some cases it's kind of self-building and self-improving. However, it's what we do with it that makes the difference. And we're seeing it accelerate the pace of analysis of data, the wealth of project data we might have, or subsurface data, tunneling data, bridge data, risk data. It's a lot of work to do. And thinking back to my time working in PMOs and construction sites, that was a lot of heavy lifting. Now with an AI agent and automation, it can cut through that data, organize it for us, pick out trends, pick out anomalies. What we shouldn't do is ask it to do the job for us in terms of decision making, but it does do a lot of the heavy lifting in a more automated, faster, and I think a more structured manner than even the best PMO leaders. So I'm really excited that AI is here to assist how our leaders run PMOs and construction sites.
Yes, yes. Sorry, I've jumped ahead a little bit there. You explained what you do at Bentley, but just summarize what Bentley does as a company.
Yeah, no, that's fine. So Bentley is a software business. We focus, which I think is really helpful, just on one sector, infrastructure. So within our sector, our software covers design, engineering, construction, and asset management of infrastructure assets across the globe. We're 41 years old. We were privately held, set up by the Bentley brothers. We're still our non-exec directors. We're now listed on the NASDAQ. A very fast-paced and exciting and successful place to be.
Good, great stuff. Thanks for that. It feels like infrastructure is becoming too complex to manage it the old way. And at the same time, demand is kind of outpacing engineering capacity. Where's that demand coming from?
The demand comes from a number of areas, and in no particular order. Most, but not all, most of the world's infrastructure, particularly in the Western world, is quite old, and so aging infrastructure is a big demand. That needs either replacement, it needs upgrade and maintenance, and in some cases we're looking at new build as well to sit alongside aging infrastructure. Secondly, climate change, whether it's temperature, wind, rain, etc. The climate is going through an era of flux. So our infrastructure gets impacted by that, and our supply chain does. So we need to consider that as well. Thirdly, population change and demographic shift. There's never been as many people in the world as there are today, and population change is moving as well in terms of demographics, age, location. So and that puts demands on infrastructure, and infrastructure's got to think ahead. And then lastly, geopolitics. We have conflicts, we have a change in demographic, change in governments, etc. And all of those geopolitical and economic factors also influence infrastructure. So it's sitting in the middle of these headwinds and tailwinds. It's quite an exciting place to be, but it is quite demanding for infrastructure, which is why we're so busy.
Yes, interesting points there. We'll touch on some of those. Yeah, the demand. So is the problem that we haven't got enough engineers to deal with the demand, or that the engineers we do have are being slowed down by poor information and disconnected systems?
I think it's a bit of both. Whilst those demands mean that, frankly, there's more work coming the infrastructure sector's way, which on the one hand is good. There is a shortage of engineers and contractors globally. That's an established reality within our sector. So we can either pause some schemes or, more excitingly, I think, look at how software and technology can help us. And it helps us in many aspects of our lives anyway, doing things that we might have done manually a number of years ago. So I welcome the fact that software, responsibly designed and thoughtfully used, can sit alongside a workforce that isn't quite big enough yet. But that software makes up for that gap. And it makes up for it in terms of the hours needed to do the work, the computational and brain power, but ultimately leaving the decision making and the human judgment to where it should be, which is in the hands of the humans. But I think it's a welcome addition to a constrained sector at the moment.
Yeah, there is a bit of a so the industry, I mean, AI is here, isn't it? It's come in inventions, but it is already here. But there is a bit of a fear element to it. It's kind of a lack of education element to it in construction, but also a little bit of fear. So people are not really on board with it as much as they should be, and you get the thing where people think, oh, this is going to take the engineers' jobs and all the rest of it. But I think it's important to note that it's not really, is it? Like you say, it is an aid to make you do those jobs easier and more efficiently.
I think that as a species, anything that's new and exciting and change sometimes causes us, including myself, to raise an eyebrow. But that should be one of curiosity. And I'm really excited that when it's responsibly coded, judiciously deployed, and really responsibly used and governed, it can be a phenomenal help to our brilliant people. And I use it most days now in my course of work, and I did when I was a contractor and an engineer. So I welcome it so long as we go into it eyes wide open, intentionally, responsibly, and like I said, it's got good governance around it, good controls around it. It truly is a great assistant for us all.
How do we govern it then? And how do we make sure it's trustworthy and that it is coded well?
Well, we can look into the code, understand the provenance of the code, who coded it initially, where, when, what was the kind of culture and mindset around? Are there any implicit biases built into the code? These are really responsible questions to ask. We can look at how insurance markets treat it from a risk perspective. If we're going to make decisions partly informed by what the code is supporting us to do, also understanding how our investors take it as well. They're viewing AI as a really exciting addition to our sector: design, engineering, construction, optimizing construction, and of course, asset management. But they do want to know that it's the right stuff and being used in the right way. So I welcome governance. We mustn't over-govern it because we could suffocate it. So I think a responsible and flexible set of principles, standards, rules, accreditations, like most new arrivals to our sector, would be welcome to keep us all in good order.
Absolutely. Yeah. I get that. You mentioned system-based thinking in our prep call for the interview. Is that basically about stopping us looking at roads, rail, water, power, and construction as separate entities and seeing them as one connected system?
One of my favorite things, systems-based approaches. I think it's two things, really. So in my opinion, and actually I was on the BBC a couple of weeks ago talking about this, the BBC News, we saw in the UK higher than normal temperatures. That impacted the rail network, which also then, because of some train delays, caused a pressure on the emergency services. They responded to stuck trains and passengers on them in heat. It also impacted our road network, and we saw delays, congestion, and sadly, an increase in incidents and accidents on the highway. That also constrained our precious emergency services. The heat also, in some regions, caused a water shortage. So as I'm talking, you can see that firstly, our infrastructure assets that previously had been viewed quite discrete are an integrated and connected system. You can also see, if you take a city like London or Manchester or Birmingham, water, energy, transport are all flowing at the same time through the same postcodes. It's a system by default and by design. And I think we're catching up as a sector to treat it as that. The second angle, I think, is on a major project. And having run and worked on major projects in the past, I've tried to bring that kind of integrated systems-based thinking to them. And I think better things happen when you do. You've got a supply chain, you've got different contractors, you've got an ecosystem going right from the tier ones down to the trades. You've got design or even pre-design, so subsurface civils, DCO, design, engineering, construction, and then, of course, asset handover and management. Our sector, as I think we both know, in the past has been quite discrete. When we stand back and look at these big projects, rather like infrastructure, they flow, the data flows, the risk flows, the opportunity flows across those different phases and stages and the points in the supply chain. So now I think the technology is there where we can truly manage all the complex components in our infrastructure assets and in a project as a system. And I'm really super excited about that, really coming to its fore in 2026.
Brilliant. Love it. That's interesting. The BBC. Talk me about that. Can you talk about that?
Yeah, of course. No, it was on BBC News. I think it was about 2 weeks ago, 2 Fridays ago. And I had a glorious 4 minutes of fame. I'm sure it's a once in a lifetime moment for someone like me. But I was asked to talk about infrastructure is connectivity, and how, in that case, with the very hot temperatures we had a few weeks ago, how rail and roads and our emergency services and our water and power networks were all independently facing pressure, but all caused by the same thing, that spike in temperature. So I think it's responsible for us to view it as a connected system. And yes, I can't speak on behalf of the viewers, but I certainly enjoyed my time there, and I hope it went well.
Right, yeah. So you spoke about the aging system earlier. Oh, actually, quickly. Yeah, so you talk about climate. So we kind of have a bit of a problem in this country, don't we? So that when we hit the extremes, either hot or cold, the country does kind of come to a standstill, doesn't it? You know, the rail, like you say, the rail of loads of hold-ups, the roads, people have accidents, and the roads, the potholes, and everything come from all the water. It does seem to me that we're not really prepared for these extremities.
Great question, and quite literally a hot topic. Look, our infrastructure has been entirely appropriately designed for our climate, but the climate's changing, and we can learn a lot from Asia and the Middle East and Africa. The Middle East and Africa are within my regions. I visit them a lot. However, they do not build their infrastructure for our climate. So if we were to directly import rail in Qatar or South Africa to Europe and to the UK, there's no guarantee that approach would work. So we've got to consider what they do for extremely hot temperatures, but also recognize that, as you said, sometimes we get below zero in the winter. So we kind of got to do that. And it's really hard. So a lot of respect for national highways, Network Rail, who try to wrestle with these extremes. But it is something that I think gets due attention and should get even more attention as climate change becomes more persistent and we face more extremes from a rather arid climate impact that's coming upon us, as we saw a few weeks ago.
Yeah, that's a good point. So that leads me on to this. So are we building the infrastructure with enough thought about the climate it will face in 20, 30 or 50 years?
I believe we are, but I believe we're starting to do it. And there are schemes that are mid-flight that I think probably can adopt and consider that as they start to conclude the construction phase. But in a business case for a scheme that's imminent or hasn't broken ground yet, I would say it's a prerequisite. And I would like to see either as a regulator or an investor or an asset owner, I'd want to understand at least that you're considering climate extremities, but also then how you're managing. And that could be a change in components, a change in engineering plans, a change in design, a change in construction methods. So I think, and it's something that Bentley would take very seriously, support planning for the extremities, but also managing the asset typically in a more moderate range. But no, I think we're starting to do it more intentionally, which I think is really welcome.
Yeah, I agree. Let's move on to digital twins. I know this is another area that you're quite passionate about. Can you explain what they are?
Yes, so a digital twin, I think, goodness me, they've got a number of different definitions, but the one I think that's most established in our sector, it's a digital representation of an asset. What's really exciting is that a digital twin, you start building it in the design phase. So you lay out what this asset is going to look like and then the path to getting it. And that can be project schedules from a planning perspective, risk logs, how extended the supply chain, how fragile the supply chain is, which components come from which supplier and in which order are they assembled. That's all really important information for maybe 5, 10, 15 years down the line when the asset's handed over. And historically in some projects, we forget to do that. Who put that bit in over there? Who engineered that pump house? Well, I've got a couple of PDFs or a memory stick. All of that goes. A living digital twin, in our opinion, starts at the earliest stage of the project and it builds, and it's a repository for all the planning, investment, supply chain, design, engineering, construction data, so that when you hand the asset over, you get two sets of keys. You get the keys to the asset itself, to the new owner, fantastic, and the ribbon is cut. And then you get the digital keys. So tell me that technology and data story right from the beginning. And it really is a once-in-a-time moment. And I'm really excited that digital twins that live the full duration of the project, have such rich and well-organized data that whoever the asset owner is when they get them, they're going to really benefit from a really solid footprint and legacy and heritage and journey of every element of that project. I know that if I was managing an asset, I wouldn't want to travel much further without it. So I really welcome digital twins.
Yeah, it does sound great. And it wouldn't just magically create this data. That will come from areas like surveys, design models. I think you mentioned this earlier, ground data, asset records, environmental information, and construction planning, right?
Absolutely. Site safety, drone surveys, which gangs, which contractors are in the fourth and fifth tier. I want to know all this stuff. Because in 30 years' time, when that asset might need an overhaul or there's an issue with the asset, I just need to know the provenance and heritage. It'll help me make the right decisions. And actually, with AI within the digital twin, it can hopefully aim off and help predict what issues might happen, interrogate the data, and present me a solution or a couple of options as a human to use my judgment on. That's very different than trawling through old PDFs and in some cases A0 schemes and plans, which we've all done. So I think life's going to get better with them.
Yes, absolutely. It leads me on to the couple of the case studies. So Bentley, you guys sent me a couple of case studies that you've worked with directly. The Everton Stadium, that was a big project. So this caught my eye because I work for Laing O'Rourke.
Right.
Well, I actually work for Select Plant Hire, which is a division of Laing O'Rourke. And I know some of the crane operators that were on that project. From Bentley's side, what was the main challenge on that job?
I mean, look, Laing O'Rourke are a really progressive tier one contractor, an organisation I hold in very high regard. So the Everton Stadium was about £500 million stadium. State of the art, it's now open, the Hill Dickinson Stadium up at Everton. And it was really complex engineering in a very constrained environment because around it you had nature and wildlife, you had open waterways, and of course you had residential and retail. And then slap bang in the middle, you're putting a massive construction exercise. So there were 6,000 components were manufactured by Laing O'Rourke off-site. So taken away and then delivered in at quieter times. We estimated it was about 3,000, was then managed at 1,200 at peak. So instantly, you got less than half the amount of human traffic, parking, congestion on a construction site. It was a digital build, 100% digital build, which meant that stadium had the digital twin right from the start. In the construction phase, I know the planner quite well, the senior planner. He built that stadium dozens of times before they broke ground, and every time they've tightened and optimized and found efficiencies. It's a really good example. Also, the marine challenges. There were some historical docks that had to be reclaimed, and technology and subsurface scanning allow them to preserve that important heritage in the Northwest and also build the scheme around it. So it's a really good example of technology helping out and reducing time, reducing footfall, which makes for a safer construction site, reducing disruption, supporting local heritage, and frankly, delivering a project in good order, on time and just under budget. It's a great case study and now a good stadium.
Now a quick word from our sponsor, WebMotion Media.
Are you ready to transform your online presence? At WebMotion Media, we're not just another digital agency, we're your partner in digital success. Our expert team delivers results-driven SEO that puts you at the top of search rankings, stunning web designs that convert visitors into customers, and data-backed PPC campaigns that maximize your ROI. Plus, our conversion rate optimization ensures every visitor counts. Don't just take our word for it. Our clients see an average of 40% increase in online revenue within the first 6 months. Ready to elevate your digital game? Visit our website from the links below this video or call us today for a free consultation and let's turn your digital dreams into reality.
On what was potentially a logistical nightmare. Yeah.
That's right, yeah. And of course it's very visible.
Yes.
The good people of Everton are watching their stadium with a close eye. The media's all around it. So not only is that exercise under scrutiny, but in some cases they might be waiting for something to happen. But no, that ran smoothly, and it's a case study we're really proud to be part of.
Brilliant. I bet. The case study, yeah, it talks about the logistical constraints and a 4D digital construction approach. I'm not going to lie, I'll tell you the truth. When thinking about 4D initially, I thought imagine something like an immersive VR headset, for example, where people could walk through the project stages personally. But that fourth dimension is more about time, isn't it?
Absolutely. Yeah.
Yeah.
It's time and schedule. And this is where I mentioned earlier, the senior planner, this is where he really saw the benefits. So Synchro is a Bentley application, and Synchro 4D absolutely does that. It brings time and schedule alongside cost into the planning, and it brings with it automation. So it takes a static blueprint, a static plan. You mentioned them earlier. We've all been pouring out the Gantt charts in the past, and this thing was not only live, but they were able to rehearse the construction exercise a number of times, tightening it and gaining efficiencies. And I went up a few times to visit the site. You had a digital PMO that had the software and code version of what should be happening on the ground. And you looked out of the window in the planning office and saw what was actually on the ground.
Brilliant. And this, I mean, additionally, this system, I imagine, is great for winning work, isn't it? I mean, you mentioned Gantt charts, so it's better to turn up with this system than with drawings and Gantt charts, and you can actually show how the project will be built visually.
Yeah, I think so. I mean, instead of a complex, disconnected text-based spreadsheet or Gantt chart, and we've all been there, by the way, site managers would now click through a chronological timeline. So the digital model physically pieces itself together on screen, step by step. Years ago, it was post-it notes on the wall and moving things around a flowchart and a Gantt chart. So I think it's really welcome.
Yeah, I think this is useful on all scales, really. I mean, that's quite a large scale project, a very large scale project. But even like your one man bands, I think this is useful for, isn't it? Rather, someone's going to a house or whatever, and you're pricing work. The owner, they want to know about amendments. They want to know how this is changing. How is this going to judge that price? The time scale on that. So you can just look at the system rather than just WhatsApping an email and texting and losing track. Just have a system in place where you can just track everything.
And according to your access privileges, it's access all round for different, the lead contractor will get a particular view. The project planner will get a view. The project director gets another view. Stakeholders and investors might get a view. Environment agency colleagues will get a perspective, but all from a single source of the truth. I mean, designers, engineers, contractors, the full supply chain. And as you said, right down to the trades to make sure that my time isn't wasted. When I turn up with my gang on site, my margins might be quite tight. So I want to benefit from the knowledge that is held in this thing. So it's one version of the truth, access all round, subject to your privileges, and it's constantly live and updated. God, it's going to make a hard job a bit easier, isn't it?
Absolutely. Let's talk about the Elizabeth line case study now. So this is kind of related to what you were speaking about earlier with the race. It's very good systems example. It's not just what's built; it's how people use it once it's open, right?
That's right. I mean, what an asset! Something for London to be proud of. I use it quite frequently.
Yeah.
It's a beautiful network. The engineering was highly complex, and I remember when I was a CDO at Costain. The engineering complexity in those big boxes that you put the new stations in was profoundly complex. But again, a systems-based approach was taken during construction and design and engineering, and of course, getting the asset up and running, getting it handed over, and now working beautifully. It's a great example of really well synchronized schedules, plans, different trades, and quite frankly, rather like on other major projects in the UK, competing organizations coming together and having a collaboration agreement and taking a systems-based approach on a project really works, because look what's happened. That thing runs seamlessly. It's something to be proud of, and we need to look at that as a great case study.
Yeah, can you just expand on that a little bit? The competing organisations, because that hits home with me, because obviously I've worked on quite big projects, but I tend to find on sometimes there's a little bit of political element to it. So you've got the contractor, you've got the subcontractors. There's a little bit of tit for tat. And I think if you can actually, get over your differences and, just actually work together on things properly, it'll be a lot easier.
I think it's about it's a difference between, or the blend of IQ and EQ. The IQ in it, we all know the organizations of the big engineering firms, medium and small engineering firms, are all quite rightly independent, competitive, and successful. Same for contractors. However, on projects like Elizabeth Line, High Speed 2, Thames Tideway, they've got to work together. Mm. No one organization wants to take on the risk. So we share it, and we share it between phases, regions, tunneling, bridges, etc. And so these collaboration agreements, I think, are super, super important. And they stop organizations. And I've been in organizations that have competed, and then you get onto the project and you work together. You have a project charter or a collaboration charter. You sometimes see even small things like not using your corporate logos, and you have a project logo and a project brand, and you're part of that project rather than working for a particular contractor. Of course, you'll always be working for the contractor from a pay and rations perspective, but having these EQ and IQ sort of elements covered is really important. But it's the EQ, I think, that willingness to collaborate that really defines a partnership model. And that also then brings on our sector together like a system. So if we act like a system of integrated people working with a common goal to deliver that project, then we used system-based approaches in the delivery of the project, good outcomes are going to happen. And that asset will be delivered as a well-integrated system by a consortia that can be proud of it.
Yeah, absolutely. Absolutely. Yeah, there's a so you've got kind of stigmas about the private sector and the public sector. I think more now they are coming together to deliver these big projects, and they have to. At the end of the day, that you have no choice.
Yeah, I quite agree. I welcome it. I welcome the collaboration agreements, and you see organisations put down their competitive instincts for a moment and get behind the project win. I think that's good for our sector and good for our country.
Yeah, definitely. So so the Elizabeth Line, so that is now done, completed using this systems-based thinking. So how much of a challenge is it now to incorporate this system into retrofitting, like you say, these aged systems that we have in place already? That must be really challenging.
Yeah, I mean, I think on the Elizabeth Line, we can see it quite nicely integrated into the underground network and the overland network in London as well. Because I think taking a systems-based approach is relatively new to our sector. If we remember that rail, highways and water assets, particularly in the UK, 200 years old, we've been doing this for a small number of years. We're getting more and more proficient in it. I think we've got a little more time to tell, a little more time to run before we can say with confidence that systems-based approaches are delivering true assets that operate as a system. We're making them operate as a system because we've inherited them, and that's okay. Managing the interfaces and the integrations, but designing them as a system and then launching them as a system, I think, is the next phase, and that's super exciting. So it's a great time to be in construction with that at the fore.
Yes, absolutely. We touched on AI earlier and real world data. I'd like to expand on that a little bit. I mentioned this point earlier as well. When people talk about AI in construction, a lot of people jump straight to fear that it's going to replace engineers, but it's not. When you've got digital twins, live data, complex infrastructure all coming together, what does AI actually help with?
So I think AI can help with a number of things. It can certainly help with spotting those interfaces and integrations I mentioned earlier. How immediately apparent to a human eye and a human mind is it that right down the supply chain or right into a 7th or 8th phase of a construction project, there might be a number of items, and they could be commodities, components, suppliers, that need to come together. We have to manually interrogate that, and I know that because I've tried it myself. Or you let well-trained AI, let it loose on well-structured data and say, find me the interfaces and integrations, and it will scan project data, scan a schedule, and say, hold on, these two things are not connected, and they should be. That is so helpful. So we don't have the oh no moment when we realize that, a load of heavy freight is turning up on a Monday and we're expecting it on a Sunday. And that does happen. Have we got the right tunnel boring machines? Those are expensive assets. Are they turning up at the right postcode or the right grid on the right day at the right hour? They need to. Well, AI can help us with that. So that's the first thing it can do. It brings precision to our planning, and I welcome that. Secondly, it can spot trends. It can spot trends in risks. So are we overloading the supply chain? Given the geopolitical issues that face our world, sadly, at the moment, are we happy, for example, with commodities, essential commodities like steel, coming through a very constrained and potentially troubled supply route? Well, AI can spot that and say, did you know that that contractor uses that supply route for that commodity? It might be okay, but look at the geopolitical risk over there. I'd rather know. So it's got that scanning capability for me. It's also good at calculating risk profile, calculating budget overspend, and hour by hour recalculating where we can redeploy project capital back into the project bank account. If we're reducing the risk on a phase of the project, because AI brings us more knowledge and we can aim off and prevent a risk happening, the budget associated with managing that risk, in theory, can get returned to the project.
Yes, enjoyable. Agreed. So I can give an example related to one of those examples you spoke about, like steel coming in way ahead of time. So I help build high-rise buildings. Some of them are on really small footprints. So you have to manage that small footprint. So sometimes we've had say we're building slabs with rebar. Sometimes we've had loads of rebar come in that are for 7 floors above what you're working on. So then that's got to be stored somewhere. You're putting stuff on top of it, and then you've got to take that stuff off of it to get to that. And it's just a nightmare. And it does my head in for start being a crane operator, giving me extra work. It's more risk because you're doing more lifts. It's just creating more mess, slowing the project down. So yeah, this is where AI helps, definitely. So that is a perfect example right there.
Yeah, I think it really does make life better, safer, faster, greener, cheaper. But just to underscore a point I made earlier, I think absolutely judgment and decision making resides with us.
Absolutely, definitely. That was actually my next question. Actually, what should the AI never be allowed to do without human judgment? Yeah.
Yeah, well, exactly that. Human judgment. You shouldn't be allowed to do that.
Bringing it back to the wider industry. So is there a risk that large clients and major contractors move ahead with this technology while smaller firms get left behind?
Well, that's a good question. I think there is a risk of that. That said, the technology that we all use or largely use in our daily lives is profoundly different to the technology we didn't even have 15 years ago. So the first point I want to make is that the technology is pretty accessible. Now, some specialist technologies aren't necessarily quite expensive. Some of the planning tools, construction tools, and you have to have a certain skill to use them, and that's okay. But we need to make sure that it's accessible economically and technically. So using natural language to go from a user, maybe a user with not much experience or training, straight into a complex engineering tool, historically has been quite hard. Natural language makes that a lot easier. You're speaking to the application in plain English, telling what you want it to do. The code and APIs then interrogate through agents the best way to answer that question, giving access to the best applications. Some will come at a cost and some might be open source. But I think that we all, right down to the trades and the individual trades as well, we all have a duty to embrace technology and think about, I don't necessarily need to be a super user on, say, ProjectWise, one of our applications, but I need to know it's being used. And then my role in that might be that I might get a report or an automated update. Well, you just made my life easier. So as you said earlier, we're not going to get the small business or the small trade turning up with the wrong equipment or on the wrong day, because that can really hurt them. So I think it can help us all if it's used in that kind of collaborative and team spirit.
Yes, great stuff. If we focus on the technology itself for a moment, what
Hmm.
still needs to get better? Is it the AI, the digital twins, or the way all these systems talk to each other?
That's a great question. I think the human interface, the human machine interface, which is a very techie way of saying how easy it is to use, that can always get better. I mean, we work with a organization called Unreal Engine, who are spin out from a Hollywood studio, and Unreal makes our engineering applications. They put a front end on it, and it makes them incredibly easy to use and very visual. So almost like watching a Hollywood movie or using gamification technologies, where in years gone by, you had to be technically highly proficient with lots of keystrokes to use some applications. They're now more intuitive. They're now more realistic. It's using a far more human and natural interface. I've talked about the voice applied natural language. So you're telling an engineering application, move the car park 30 feet to the left. That in a planning tool might not be 30 feet, might be 27 feet, but the software knows that, so you don't have to. So it's just, I think, so the human interface is really important. I think AI will be looking after itself with that good governance around it. So I don't worry too much about the pace of AI development. In fact, I think that's happening at a really exciting pace. How it's used is the application of software that I think our industry needs to get better at. Not using software for software's sake, not using it for everything all of the time, but working out on a major project before you get going, what does our technology strategy look like for the project? What applications, what APIs, what systems, what data flows do we need? What don't we need? Where do we not want to use it? I think they're really important. They are really important considerations. So that's less about the tech, and that's more about how we use it and when we use it. And let's also remember that we want that technology to leave a bit of a legacy as well. So what we're learning with AI alongside us, and how can we then take that to the next project to scale those efficiencies and frankly never make the same mistake twice.
Yes. Yeah, I think the human interface is a really important one actually, because you don't want to have to do a degree to be able to learn how to actually use the AI. That's kind of counterproductive, counterintuitive in itself, isn't it?
Yeah, that's right. I often say if I can get my mum to use it, we've probably got it about right, which makes it very accessible, which is really exciting.
Yes. Brilliant. We are done with you. You made some really, really great points there. And what I normally do now, I tend to invite the guest to ask me a question. So would you like to ask me a question? If so, do you have one at hand?
I would absolutely love to. What do you think is the most exciting future application of AI? Where do you think it can help us in the near future, from your experience operating, heavy plant?
Operating heavy plant. So, yeah. So, I'll actually talk about something Select are doing actually. So so for a plant hire company, you've obviously got lots of plants. So they're producing a teleclimatic system where you can monitor the machine's usage, the power output if it's supplied by the mains power source, power output, which is great for the carbon footprint, maintenance, shutdown time, breakdown time, fuel efficiency. So all of these things are talking to each other. So that can help them to produce better packages for their clients in the future. That's one aspect for me, particularly on tower cranes. So for me, I use to lift loads. It uses a certain amount of oomph, a certain amount of power. So companies, they want to know, well, how much power are we using on this project, so they can look at that and go, okay, so for this lift, massive 20-ton lift, this is using this certain amount of power, so they can monitor that, wind, downtime, all that sort of stuff. Yeah, it's exciting.
And that's really interesting, isn't it? And that literally comes from your seat, the kind of view from your seat. That AI could help your organization to help Select manage its power output, which is great for the environment, great for the bank balance, can also support site safety as well, and operative safety as well. So what a great practical example. I think it really can help us all. Like I said, if it's got the right
Yes,
the right
absolutely,
protocols and responsible usage around it.
absolutely, I'm saying that from for a year or two ago as a real naysayer. Oh no, AI, no,
Yeah.
can't use that. Don't
Yeah.
want to use that. No, and I'm converted.
Well, there we are.
Nathan, it's been brilliant. Thanks so much for your time. It's
It's a
very
pleasure. I've
insightful.
really enjoyed it. I've really
Good.
enjoyed it. Thank you
I'm
for making it very enjoyable and interesting.
I'm pleased. Then I'm more than happy to do it again in the future on another topic or on
About
this
that.
topic again. Yeah, great stuff. Enjoy the rest of your
Love to.
Sunday.
Yeah, take care. And you. All the best. See you
Thank
soon.
you. Bye.
Bye, Jimmy.